The spectacular facilities of the church were well maintained until difficult economic times caused necessary maintenance to be deferred. The soot-filled air and acid rain from the steel city took its toll. Over 100 years after the church was built, a renaissance took place to reclaim the city's brilliant resources. A unique partnership between the church and the Allegheny Historic Preservation Society was formed, with the goal of preserving this unique building and restoring it to its original splendor. Funds were raised, and in 1994, work began on cleaning the exterior. By 2001, it was obvious the deterioration and damage to the Tiffany windows must be addressed. A complete restoration was needed. Unlike many works of art, stained glass windows are an integral part of the structure of a building and are exposed to the daily onslaught of the weather. A Tiffany window is unique because he used layers of glass to create a spectacular blending of color. Dirt and soot over the past century have slowly built up on the surface and between the layers, causing the brilliance of the light to be muted. Subtle color changes have turned drab. Before restoration begins, it's important to conduct a detailed inspection. This establishes the condition of the glass, the supporting frame, and the overall stability of the window. A window of this size is a series of panels, each weighing about 70 pounds. The support for each panel comes from reinforcing bars and T-bar dividers anchored into the stone. Wire ties soldered onto the lead are wrapped around these steel bars, and the bottom of each panel rests on a T-bar. This support is critical to the health of the window. Evaluating the condition of a window takes an experienced eye. From a few steps away, the beauty of the window dominates your view. On closer inspection, damage becomes obvious. You can also see problems created by previous repairs by less informed practitioners of restoration. The primary material responsible for the structural integrity of the window is the lead cane, which is a British term for extruded lead channel. It is soldered together at intersecting points and physically holds the individual pieces of glass in the sophisticated patterns that form the panels and ultimately the entire window.
The lead and glass are very different materials. They have very different expansion coefficients. And over a period of time, the lead takes quite a bit of abuse since it's the more elastic material. However, as it ages, it becomes quite brittle and eventually begins to crystallize, at which point the window moves out of the vertical plane and gravity takes over, speeding up the deterioration process.
Natural deterioration of the lead occurs both mechanically and chemically. Mechanical deterioration is the most prevalent form, especially in windows approaching 80 to 100 years old. Chemical deterioration, in the form of oxidation, also affects the strength of the lead. This is often caused by condensation that gets trapped in unvented storm window or protective glazing systems. The most obvious manifestations of lead deterioration are bowing and buckling of the window. As this progresses, mechanical deterioration of the lead becomes more evident. During advanced stages, lead tears away from the panel, reducing the overall strength of the system. Of more concern is stress on the glass, which represents the true value of the windows. As the lead deteriorates, the weight of the panel can fracture the important individual pieces of glass. As glass becomes loose, the original sealing material, referred to as cement, falls out, allowing dirt and moisture to accumulate between the layers. This diminishes the aesthetics and deteriorates the window internally, where dirt can etch the glass and moisture can oxidize the lead. Nature and time aren't the only threats to this work of art. Previous short-term repairs have resulted in significant changes to the original work. Instead of restoring fractured pieces, poorly matched new pieces were installed. A new lead line, not part of the original design, was used between two broken pieces of glass. Lead, larger than the original, was used to rebuild damaged sections. Patchwork repairs like this may hide the problem for a few years, but solve nothing. Complete restoration, including replacing all of the lead, will give this window new support and strength for the next 80 years or more. This method has been used in Europe for centuries. Here in the United States, many churches are just now reaching the age where total lead replacement is needed. Before removing the window, photographs are taken to document the original